welcome to this webinar today on EGDC Case Study Calculators, which is being organized by the EGDC Pilot Project. I will first start with a few housekeeping rules. The webinar is being recorded. Please do not activate your camera and your microphone during the webinar. There will be a Q&A at the end of the webinar. So you will be able to raise your hand, and once given the floor, you can activate your microphone and camera if you want, or you can also send your questions via the chat. And now let's move ahead to the agenda of today. We will start with some words of introduction from Luis Neves, who is the coordinator of the Green Digital Coalition Pilot Project. Then we will have an overview of the EGDC calculators, their purpose, their goals, their timeline by Veronica from the Carbon Trust. And then we will deep dive in the two first case study calculators, which are being currently developed. So by the Carbon Trust and by Deloitte, with submissions from Schneider Electric and Ericsson. Then we will give the floor to the providers of these solutions for some reflections, and we will open the floor to Q&A from the audience. So without further ado, I would like to give the floor to Luis Neves, CEO of GESI and the coordinator of the pilot project. Luis, you're muted.
Yes, my apologies. Hello, good morning, everybody. Welcome to this workshop where we will be presenting to you the case studies. I will not take very much time because I think it's important to go to the interesting matter that we want to discuss. Just to welcome you and say a few words about the European Green Digital Coalition. Today we have currently 36 member companies and 4 supporting partners. And as you probably know, to support the European Green Digital Coalition and its goals, the European Commission has funded this project together with the European Parliament. And the partners of this project along with GESI are the European Digital SME Alliance, Digital Europe, GSMA, ETNO, the Carbon Trust, Deloitte, and the ICT Sustainability. So together we have been working now for almost 1 year, and we are coming now, I'd say, to the first phase of the project, and we want to present to you today some results. I don't know how much you know about the coalition. Any company that would like to join the coalition and also the partners, they need to fulfill some criteria, and they do that through the signing of a declaration, which includes 3 key actions. One is investing in the development and deployment of green digital solutions with significant energy and material efficiency that achieve a net positive impact in different sectors. Then the second one is developing methods and tools to measure the net impact of the green technologies on the environment and climate. And the third one is co-creating with representatives of the sectors, recommendations and guidelines for green digital transformation of these sectors that benefits the environment, society and economy. Now we are very much focused on solutions that are closely more related with the environmental side and the net positive impact. But I hope that later on we also can look into, in the context of this project, to other dimensions of digital technologies and its enabling impact as well. And so with this project, the Commission made clear that there are clear expected outcomes. And that's what, you know, all the partners together with the companies and the partner organizations are working on. We are working on developing the KPIs to measure to what extent companies are investing in the deployment and development of green digital solution. Secondly, we are working on the methodologies, and we'll talk about it today. We're looking into different case studies. We committed to analyze at least 18 digital solutions, case studies in the different sectors like energy, power, transportation, construction, buildings, manufacturing, agriculture, and smart cities. So these will be our priority areas. And finally, we will be developing and deploying guidelines to guide the implementation of green digital solutions, which have an impact on the environment, the society, and the economy. And so these guidelines are meant to prevent unintended negative consequences of deployment, including reward effects, and help the parties to adapt their specific situations to unknown or unforeseen situations. So this is what we are working on since beginning of this year. The project will continue along the next year. And today we would like to present you some results through concrete case studies. And so I will hand over to Deborah because I think, as I said, it's important that we go to the subject matter. And thank you so much to all of you for attending the meeting today. And please feel free at any point to ask any questions that you might find relevant. Thank you so much.
Thank you very much for these words, Luis. Indeed, let's move to the core topic of today's webinar, which are the case study calculators, one of the actions of the EGDC Pilot Project. I will give the floor to Veronica Thiem from the Carbon Trust.
Fantastic. Thank you, Deborah. And good morning or good afternoon, depending on where you're joining from today. So before we dive into the case study calculators that we want to share with you today, just a quick overview on the case study calculators, what the purpose is, and our progress so far. So as mentioned, we're developing 18 case study calculators, and the purpose of these case study calculators is to provide essentially examples of practical applications of the methodologies that we're developing on real live digital solutions. And so essentially what these calculators will do is they will estimate the net carbon impact of digital solutions and determine whether these solutions can indeed be considered a green digital solution if they're showing that they provide a positive carbon impact on other sectors. So far, we've developed 2 case study calculators, which we will share with you today. And each of these case studies is comprised of 2 parts. So a case study calculator, which is essentially an Excel spreadsheet showing the results of the calculations, and also a methodology document, which outlines the calculation approach, any assumptions made, the data sources used, and essentially provides further transparency around this process. And a very important note is that the calculators we're sharing with you today are currently still being reviewed by external experts from our advisory board, and they will be revised early next year. And in terms of the use of these case study calculators and what how you might look at using them and how they can be used in the future, of course, the first thing is obviously that they will help the user to assess the impact of the digital solution. But very important to note is that this is only within the context of the specific use cases at hand, which are outlined in the methodology document. The other important thing that these case study calculators will do is they will outline the calculation approach that can be used for calculating the net impact of these types of digital solutions. And so they provide users with an approach that they can then replicate using their own data and their own specific use case to replicate the calculation approach. What the case study results should not be used for is essentially just using them without considering the specific parameters of the use cases and the scenarios under which these calculations have been performed. In terms of next steps, so overall, as said, we will look at developing 18 case study calculators. So far, we've developed 2 that we will share with you today. And the immediate next step is to develop 7 to 8 additional case study calculators by sort of springtime next year. And these are currently being developed and will cover digital solutions across all of the key sectors that we're looking at. So that is agriculture, power, energy, building, construction, smart cities, manufacturing, and transport. Great. So we now want to go further into the 2 case studies that we've so far developed. So starting with case study 1, this is a case study that was submitted by Schneider Electric, and the digital solution in question is a high-performance building management system, which essentially allows for the control of air quality, temperature, occupant comfort, lighting and heating in buildings, and the energy reductions, and therefore obviously also the greenhouse gas emissions, come from the additional implementation of IoT sensors in this high-performing BMS. And so what these sensors do is they increase the efficiency of the occupancy CO2 monitoring. They help with the light and blind controls, and therefore enable the HVAC and light demand to be essentially controlled based on occupancy. And so what this high-performing BMS does is it allows both for real-time monitoring as well as optimized energy control within the buildings that the high-performing BMS is implemented. And so due to these capabilities, the high-performing BMS, which is the digital solution we're looking at for this case study, has essentially carbon-saving impacts, both compared to other advanced BMS systems as well as to a standard BMS system. And so when we approached this solution, we actually therefore considered 2 different scenarios to compare this digital solution against. So 2 what we call reference scenarios. So the first reference scenario that we're comparing this digital solution to is a standard BMS system. So this is a sort of a more basic BMS system that provides obviously less savings than both the high-performing BMS solution that is provided by Schneider Electric, as well as other advanced BMS system. And so this is sort of the typical BMS system or a basic type of BMS system that you would see in most office buildings. And then the second scenario that we're comparing the digital solution against is a advanced BMS system. So this is the essentially supersedes the savings against the standard BMS system, but there's still differences compared to the high-performing BMS system, and consequently the high-performing BMS system enables again more carbon savings per square meter than this advanced BMS system. Great. If we move to the next slide then. So to give a bit more context in terms of how we've approached these calculations and how we've calculated the net carbon impact of this digital solution that we're looking at. So there were 2 different routes that we took for calculating the net carbon impact of the solution. So the first route is based on essentially the modeling of archetype data from the Schneider Electric sustainability tool. So this is modeled data which provides both energy consumption figures for different types of buildings, as well as the energy, so electricity and gas saving figures for 5 different countries. And what we then did is we used those 5 different countries essentially as proxies for different climate regions across Europe. The second route that we took is to actually use real life data from sort of measured reductions using data from 2019 and 2021. So looking at the building consumption at one of Schneider Electric's own buildings in France. This uses Schneider Electric's BM assessment tool. So looking at this building, but then also essentially doing 4 additional simulations where we essentially take the Technopole building where that real life data is coming from and place it in 4 other cities and in 4 other climate regions to then again assess the varying impact that those climates would have on the savings. In terms of the assumptions that we've made, first of all, in terms of the sort of countries that were chosen, obviously we've had a limited number of scenarios that we had to deal with, and so obviously we have made some assumptions when matching the countries where the simulations were done to the respective climate regions. And then the other assumption is that we've made that there's sort of no direct rebound effects for this solution, as any rebound emissions from, say, the changes in the temperature settings are already reflected in the percentage reductions of the emissions based on the energy consumption data that has come out of the 2 different data collection routes. So before I switch over to the actual case study calculator and show you what that looks like, again, one important thing to note is that the calculator allows for several variables to be input into the calculator to show the variation in results. So this includes the varying of the on-site renewables as a percentage of the total electricity consumption in the buildings. It, of course, allows for the selection of the specific climate region and then also of the specific country selection as well. Of course, the emission factors will then need adjusting if the location is not one of the defined options. And then it also allows for changing of both office size. So you can either select between different office sizes, so large, medium, or small, or this can also be overwritten manually, so you can change the office size, as well as change the average both electricity and gas consumption per year, which again, under the default options, sort of depends on the climate region and the office size, depending on the Schneider Electric sustainability tool, but there is also the option of overriding that manually and changing those input variables. In terms of the control variables, so important to note that the calculator estimates the energy savings per square meter in a sort of typical office building. And so that typical office building is defined and includes a number of variables that are fixed and do not change. Also, one of those aspects is that the sort of building control architecture is distributed and measured based on savings measured by zone, and each zone is defined as being 17 square meters, which includes 6 desks and consists of sort of 1 combined light level occupancy sensor, and then combined temperature, relative humidity, and CO2 sensor, as well as 1 zone controller. So that is something that is defined within the case study calculator itself. In terms of the results, so again, these will vary depending on the input variables that are selected, but the results are displayed both in terms of savings of kilograms of CO2e per square meter, as well as percentage savings and also total savings if you input the overall office size that you're looking at. And then, of course, it provides savings both for comparing the solution against the standard BMS as well as the advanced BMS systems. And you can see here the results in terms of how much they vary. So comparing it to a standard BMS system, you can see that it provides electricity savings between 13 to 20% and gas savings between 28 to 30%. Whereas when comparing it to the when comparing the high-performing BMS to the advanced BMS system, it shows electricity savings of between 7 to 10% and gas savings of around 11%. So that's a hopefully has given you a bit of an overview of the case study itself. What I now want to do is just very quickly share with you the calculator itself and how that works. So I will try to share my screen. So if you just bear with me. So let me know when you can see that.
Yes, we can see it.
Fantastic. Great. So the main tab within the calculator is this first tab here, which allows the user to select a number of input variables. So it allows you to select the specific country that you're looking at. You can then select the office size, so small, medium, large. But as I said, that is also something that you can then override at a later stage. It then allows you to select the reference scenario. So whether you're comparing the high performance system to a standard BMS system or to an advanced BMS system. And then for each, it also allows you to select the energy consumption type and the route that you're using to calculate the savings. So when comparing it to the standard BMS system, the only route that's available is this route 1, which uses the modeled archetype data. So it then, essentially pulls through some default average consumption per year figures. It pulls through obviously the allocated climate region, as well as the assumed on-site renewable energy generation, which is as a default at 0%. But all of these variables, again, allow for a manual override if that is something that you would want to look at. And then at the bottom, you can see here that it then shows the results. So it shows the electricity and gas savings as a percentage, as well as the carbon saving enablement factors, so the savings per square meter, as well as total carbon savings enabled. When selecting the comparison against the other reference scenarios, so comparing the high performance to an advanced BMS system, it then allows you to select between the two different routes, so both route 1, which uses the modeled archetype data, as well as the route 2, which uses the real actual data from the Schneider Electric building in France. And once again, that also allows you to put in your annual electricity consumption as well as floor area, and then pulls through initially the default climate region based on your selected country and a default on-site renewable energy generation, but again also allows for the manual overrides. Great, so hopefully that's given you a bit of an idea of how the calculator works and the different options that are available. Once again, just to reiterate that these calculators are still being reviewed by our advisory board, so there will be changes that are being made. But as I said, we hope to finalize at least these first two calculators early next year. Great. And with that, I'll hand it back over to the team to present the next case study calculator.
Thank you very much, Veronica. I will share the screen for the next presentation from the Deloitte team.
Brilliant. Thank you. So yeah, hi all. I'm Jack Simpson, a senior consultant at Deloitte, and I'm the technical lead at the Deloitte team overseeing our contribution to these case study calculators. And today we're going to be talking through the Ericsson calculator that we've helped with. So I'm going to pass over to Diane, who's going to lead us through the case study, both methodology and the initial calculator results.
Fantastic. Thank you, Jack. Good morning, everyone. So I'm going to run you through how we constructed the Ericsson case study calculator. So if I start with the premise for the study for the calculator was the Coriolis Port of the Future project, which is a program that was funded by the EU. And the purpose of this program is to build a framework for ports to help them meet future challenges of increased traffic and capacity concerns in a sustainable way by leveraging data and digital solutions. So the Coriolis project was set up across 5 European ports, of which the Livorno Living Lab was one of them. So our case study focuses on the Ericsson 5G Port of the Future solution, which was implemented at Port Livorno in Italy. So the solution leverages the use of a private 5G wireless network, which enables the use of VR and AI digital solutions to help optimize the use of operations within the ports, in particular the use of port vehicles when handling and processing cargo freight. So in the case of Livorno, to increase the efficiency of operations, Ericsson implemented logistics management softwares enabled through the installation of the 5G wireless network. Go to the next slide, please, Deborah. So the key starting point when constructing the calculator is defining the scope. So if we look at the overall Coriolis project at Port Livorno, the activities look at a number of logistics management softwares, and because of the way the data availability and the specific area of interest where the solution had the most impact, we decided to focus the study on the implementation of the RT Port logistics software. So the RT Port module enables the optimization of use of forklifts, as well as instant data processing. So that helps with instant registration for forklifts and cargo. So in the case of emission savings which were enabled, this was achieved through reduced activity for forklifts and associated fuel savings, which saw decreased emissions for handling the same amounts of cargo over a year. So if we look at the data collection, so again, the data was collected on the field by Ericsson in the context of the impact assessment report for the Coriolis project. So the baseline scenario was set in 2017 prior to the implementation of the 5G network and the logistics management software. So in a sense, this was prior to sort of optimizing the routes for the forklifts, and also registration process was done manually. So a waybill would be delivered to the offices manually by the forklift driver. So that was our baseline scenario. The post-implementation scenario was measured over 2020 to 2021. So this looked at running times for forklifts the distance traveled and the fuel consumed. And so this was all data which was collected by Ericsson and provided provided within the context of the impact assessment report. Other variables which we looked at were the emissions intensity of the diesel fuel for forklifts. Had the scope been wider, we would also have looked at other yard vehicles at the port, but like I said, the scope was defined to the yard movements of forklifts. So the findings of the study, they demonstrated that through the implementation of the RT port module and the 5G network, forklift running time was reduced, as was the associated fuel use and carbon emissions. And for yard movement specifically, there was a reduction of fuel use of 20%, which led to associated reduction in carbon emissions by 20% as well. If we move on to the assumptions and sort of considerations to take into account when applying this case study to wider applications. One of the key points, as with the Schneider Electric example, is that in the use case at Livorno, there were no rebound effects that were identified. So a rebound effect would have been, for instance, if the forklift activity has reduced for processing the same amount of cargo, then that might enable the ports to actually process more cargo freight within the same time period, and at an aggregate level would increase emissions at the port. The reason this wasn't the case at Livorno is because of the shift patterns for the forklifts which operate alongside cranes when unloading and handling cargo freight. So in our case, the forklift shift was brought down from 14 hours to 12 hours daily, which sort of meant that it aligned the shifts for forklifts aligned with the shifts for cranes. So didn't allow for increased capacity at the port, but that would be a key consideration to take into account when looking at other applications for the digital solution. And then another consideration is the type of freight handled, because when dealing with general cargo, the nature of cargo handled is very heterogeneous. So unlike container freight, which is obviously standardized sizes, there's a lot more variability in the type of items unloaded, and that obviously affects the smoothness and the efficiency of running operations. So in the case of Livorno, the order of unloading freight is predetermined, so that reduces the variability of daily operations because there's an additional element of efficiency, which allows for greater comparison. So if we go on to the next slide. Thank you. So these are the variables which we've considered for the case study calculator front end tab. So in a moment, I'll run you through the front end of our calculator as well. But to give you a brief understanding, so we've extracted relationship based on the Livorno case study. We've extracted an understanding of how your running time for forklifts and yard vehicles is impacted by the application of the 5G Ericsson solution. So based on this on this relationship which was identified, which we've extracted from our case study, we then take our We then take our case study and had to think about how the best way of capturing changes in sort of the scope and the scale of the port could be best captured. So this was agreed with Ericsson. The best way we thought of kind of looking at differentials between different ports would be to look at the total freight tonnage, which is processed annually at the port. So this allows comparison at a very high level, very indicative level. It allows comparison across different ports of different capacities and capabilities. Port Livorno is one of the biggest ports in the Mediterranean, but you kind of get a scope and a scale. It gives an indication of, that the bigger, the more important the amount of freight processed, the more potential for impact of the solution. So this is why we were looking at freight tonnage. In terms of control variables, our override options look at drilling down at a more granular level, still a fairly high level, of course, and that was to capture sort of the specificities relating to the yard vehicles, so the forklifts. So looking at the vehicle running times, so the shift patterns, also looking at fuel consumption, which kind of captures any differentials between vehicle type, vehicle model, also the age of the vehicle, and the vehicle's fuel emission factors, which in our case for the forklifts was diesel fuel. If we look at the results, when expressing the results from the calculator, the functional unit selected for the carbon savings to express the carbon savings is the ton CO2 saved per million freight ton processed per year. Again, to bring it back to the sort of capacity of the port as a comparison point, the freight tonnage is included. And so just to stress again, before I move on to the presenting the actual calculator, the output, which is captured by the calculator at Ericsson, is very much an indicative value of what could be achieved from the solution. But of course, this is very much based on the use case scenario at Port Livorno within the context of the Coriolis case study itself. So it's very much to be taken as sort of like an academic research point of view, and very much an indicative value of what could be achieved through the solution, rather than a clear-cut view on emissions which would be saved by applying the calculator. So I will now share my screen and talk you through the front page of our calculator. Are you able to see my screen?
Yes.
Fantastic. So as I've just said, the input variable we chose was the freight tonnage per year. So you can see that's included in the top row. And then the idea is that you drill down with the controls for added insight. So very high level indication through by having an indication of the port's capacity. And then these default values here are those extracted from the Ericsson case study at Livorno. But the controls can be adjusted. So we have these manual overrides, so selecting the options for an override here. And then these override options will filter through to the back end of the calculator, which is where all the the computations carry through. And then the results, as I said, so we have an indication of the forklift fuel, which is saved through the use of the solution. And carbon savings enablement factor, as I said, functional units, tons CO2 per million freight tonnage processed per year. And then final output of the calculator is the total carbon savings enabled by the solution per year. So that was a very brief overview of the Ericsson case study calculator. I'll now hand back to Deborah for the remaining of the session. Thank you.
Thank you very much, Diane, for this presentation. I see there are already a lot of questions and interaction in the chat. And before we go over to Q&A, I'd like to give the floor to representatives of the providers of the solution for these two case studies. And we will start with the representative from Schneider Electric, Vincent Minier, who will provide a few comments and feedback on Schneider Electric's experience providing this case study, or any other comments you would like to make. The floor is yours, Vincent.
Thank you, Deborah. I hope you can hear me well.
Yes.
Okay. Yeah, just a few comments. First, I'd like to congratulate the team and the Carbon Trust team and all the EGDC team, because it's a first of its kind exercise, and it was not so easy because hell is in detail. So it was kind of a tough work, but worth to make it, especially when you work with real cases. We started from a building which got built which got equipped in 2018, and doing all the calculations and the reverse calculation to extract the value of the system is not easy, but it's worth to work on real cases. We were not helped by the COVID. The third point is that there was two questions I can answer very quickly. We took obviously the embodied emission of the solution, all the IoT sensors, taking into account the manufacturing, the transport, and so on. And we took the operational emissions of the IoT solution, namely the consumption of the devices plus the on-premise IT infrastructure for storage, data storage, and data collection. So we really took everything on that solution, which was not a cloud-based solution. It could be a cloud-based solution, but it was not. The third point is it's really valuable to start from a real case and extrapolate at EU level. The real case was a building with an electric heating with heat pumps, and it was a reversible heat pump on one side. On the other side, it was in France, so with decarbonized electricity. So when extrapolating to Europe, we took into account the CO2 grid content, the fact that could be gas heating. So it was very important. Another point which is important when working with the calculator, when we did one of the road is taking into account archetypes of building, taking into account the way the building is designed from an envelope point of view and equipment point of view. So when doing the extrapolation, playing with the calculator, you have to take into account that it will not be exactly the same in real buildings you would like to simulate, to model. I think it's last point is that we focused a lot on the savings and in energy savings and emission saving of this high performance BMS. So you saw the figures, but it's on top of the role of a standard BMS, I would say, which is already recognized as a saving tool by the Commission and by the PBD, notably as a saving tool. So the figures you find are to be added to the savings of regular BMS. I'll stop here, but great work with the team. Thank you very much.
Thank you very much for sharing these comments, Vincent. And now I'd like to give the floor to Pernilla Bergmark, who is a researcher at Ericsson and who has worked on the case study from Ericsson's side. The floor is yours, Pernilla.
Okay, thank you very much. And I'm, as you say, a researcher in ICT and sustainability at Ericsson, but I'm also leading the work of a methodology from ITU on this topic, on how to calculate this type, do this type of calculations, which will be actually be published next week, and which we hope to merge this work closer to that. But of course, at this stage, because that's a quite strict framework, and we have seen some questions in the chat already in relation to footprint and so on, and we hope to move this work closer to that over time, but at this stage that has not yet been done. When it comes to the case study as such, I need to point out that this was a case that was originally not developed for a carbon assessment, but it was more from the sustainability perspective to find a way to identify connections to SDGs. But we sent it in, but that means that it has not, from our side, before it wasn't in as a case, been evaluated as a case, which is why we had not data on embodied emissions, for instance. With the team, it has been agreed that that should be added as a next step. And I think from participating in the methodology development in the EGDC, that there are a lot of complexities in the way to consider embodied emissions, especially if you have shared equipment. So that is something that I think we will learn from as a team, but it is the next step, but it's not forgotten. Then I think, as this is framed as a calculator, that comes with an expectation that you can have some sort of reuse of the results, although both Veronica and Diane stressed that one has to be cautious with the figures. And one thing, of course, about that is that this is a quite small, you can almost call it a laboratory experiment, although it is in a real life setting. So it's not a wide usage of this type of solutions across different harbors, across over a very long time, etc., which means that it is indeed a case study. And to evaluate one case study that is different from using that case study to extrapolate. And I think from a methodology development perspective, that is something that we would need to consider more. How do we really want to use that case studies, and what would be the extra levels of validation, perhaps not so much so to additional instructions and considerations that would need to be added to them to use them as a tool to look at other similar solutions. So that would be very important. And we know from, I have seen that Vlad Kurama is here. He was writing a paper some years back with a colleague of mine where they looked at the potential of electricity or of smart metering, and they found that there was a reverse relationship between the size of the case study and the experience potential. And there are a number of reasons for that, but those are things that would need to be considered in the next steps of the project. I took down some notes what I wanted to mention more. Yeah, so this is built on a small scale, so one should be careful with numbers. And also regarding how a case study like this could be used, and if one would in the end need to look at more parallel studies and then to do some kind of consolidation between those and use that as the default values. So I think the next step is really around the applicability of the calculator. It's on adding the embodied emission. It's to look at the potential to have a wider set of case studies to feed into one calculator. And it's also about the alignment with the standard and to allow for further complexities in relation to the methodology. So for instance, this is an ex post assessment. It's based on a case that has already happened. If we would like to do an ex ante, would we take exactly the same methodological approach, or would we have to modify it slightly? Yeah, okay, I stop there. Thank you so much.
Thank you very much, Pernilla, for these comments and these thoughts. Since we have only 9 minutes left in the webinar, and since some questions from the chat have already been answered via the chat or via the comments from Pamela Bergmark and Vincent Minier, I would ask people whose answer has not been answered, whose question has not been answered yet, to raise their hand, or any other person who wants to ask a question to please raise their hand. So just to give you the floor and ask your question. Okay, let's start with Pepe Betancourt. I think you have raised your hand. Okay, if not, we can go to the next question. I only see the last name, Mr. Kowalczyk. Yes. The floor is yours, Marceli. Marceli Kowalczyk, if you want to ask your question, you can activate your microphone. We see you on the camera, but we cannot hear you.
Hola, buenos días. I am no speak English, sorry. Is possible in Spain? In Spanish?
I don't know if anyone of you speaks Spanish.
Okay. Bueno, pues nosotros necesitamos el análisis y el coste y justificar el coste del ciclo de vida de los sistemas de productos.
If I understand,
Okay.
it's about life cycle, cost of life
Yes,
cycle assessment.
I can try to translate what Pepe is saying. So he is saying that they need to justify the cost of the life cycle of the solution.
But, pero basados en la economía circular,
based on the circular economy,
vamos a necesitar materia prima de basura, de rechazo de nuestros turistas que nos visitan anualmente.
Pero Pepe, yo no sé el contexto de tu pregunta. Sorry, because
el contexto es que sí se tendrá en cuenta el origen de la materia prima del compuesto del producto analizado.
Okay, so what Pepe is saying is that he's wondering if in the life cycle assessment of the solution is going to be considered if the device is using, for example, recycled material, if the origin of this material that is being used in the device.
Muchas gracias, Ana Belén. Te lo agradezco muchísimo.
No hay problema.
Hablo un poquitito de español. So, no, on our side, what we took the product environment profiles of the sensors, where you have a full life cycle analysis of the sensors till end of life. Okay.
Okay.
So we take into account the end of life. Okay. And for sensors, for example, we have a sensor with a battery. So we took a lifetime of 10 years. So if you want to extend to the full life cycle, you need to add the more batteries and so on and so on. Okay, but we took the life cycle analysis on our devices.
And for the other case, it was not set up as a carbon footprint or a carbon calculation from start. So we have not performed that that assessment from Ericsson's side, and we agreed with the team here that specifically for the calculator that would be a later step to add that for this in this context, specifically for this project.
And I think maybe more generally to add, for these calculators, I think this is one of the things we're also discussing as part of the methodology that we're developing in terms of how to really incorporate the embodied and the use emissions of the digital solutions themselves. So I think we definitely want to put more emphasis on including this, as many of you have also pointed out in your comments. But I think there's also a question around the level of granularity for these calculations, as a lot of that life cycle assessment or the data needed to do a full life cycle assessment for these digital solutions might not be available. And oftentimes these emissions are, while obviously still important, relatively small compared to the sort of savings. So that's something that we're looking at further also as part of the methodology.
Thank you. We can move to the next question from Pedro Cravo.
Good morning. My name is Pedro Cravo, and I'm new at this group, and I will want to know how can we participate with our platform for agronomic situation. With whom should I speak to present our platform? And that could be something that could minimize the water, the energy, the GHG situation, and so on and so on. Thank you very much.
Anyone wants to take this question?
I think from Luis Neves, because it's the master of this group, should be.
Well, we will still have a third open call for submissions for solutions which might qualify as case studies. So we will keep you updated, and if your platform is suitable, it will be nice to apply.
But,
okay.
Well, Deborah, what I suggest to the question is that you contact the Secretariat, and then we will set up a meeting with you, a call to understand what you have, if that fits into the project or not, so that we can consider that for the second phase.
Where did I find the
Well, we have a website.
Mail.
We have a website of the coalition.
I will type
Maybe,
in the chat.
Oh, okay. Thank you very much.
Okay, while I type the information in the chat to contact us, we can move to the next question from Maciej Kowalczyk.
Hello, can you hear me well?
Yes.
Okay. I'm representing as an observer part of EU Commission that is looking at the various solutions for climate mitigation, including energy efficiency ones. So it's very interesting for us for the work you do with various cases. In particular, we are also trying to promote the heat pump based solution as a viable alternative in the nearest future. So I understood that in Schneider case there was some kind of relevant assumption being made for more like gas heating, and maybe I can exchange with Vincent bilaterally on the extrapolation method you used. But my question maybe is for a little bit for the future. would you maybe undertake at some point similar exercise for strictly heat pump based solution to show whether there are any further potential savings in heat pump based solution using smart, let's say, smart layer of let's say of the smart control? Okay, thank you.
Yeah, thank you for the question. The solution was a smart, an IoT-based BMS, right? But are you talking about smartness about the heat pump? We do manage the heat. I mean, the real case was a building with a reversible heat pump, industrial reversible heat pump. We have a lot of that in France, and to extrapolate to the EU level, in fact, we have a given heating need in kilowatt in this building, in kilowatt hour, and we can extrapolate the needed gas knowing the cup of the heat pump. So the real case was a heat pump based, but we could easily extrapolate to a building which would not be with a decarbonized grid, or which would not be heated with a heat pump. So we do manage the heat pump through our BMS. We control the heat pump with the BMS. We may have a separate conversation if you want. Very happy to have this conversation.
Okay, so let me approach you by email. And thank you very much for the work.
Happy to do so. Thank you very much.
Thank you. And we are conscious of the time. We will take one last question from Idris, and then we will move to the end of the webinar.
Yes, hello. So thank you very much for your presentations. I was wondering here, because we also talked about consolidating with several other use cases, and comparing the solutions is very important for us. Most of the time we are not measuring directly the carbon footprint by measuring how much carbon dioxide you have in the air, but you're doing this indirectly by measuring, for instance, fuel consumption or energy consumption. And here I'd like to know if there is a common reference that we are all using to calculate this, because you need some figures, obviously, to estimate that a certain kind of energy or a certain kind of fuel will produce that many tons of carbon dioxide. And here, to make things comparable, we really need to have the same source, all of us. So are there here figures which are already, which were given from the European Union side, for instance, where we all start from the same statistics?
I don't know if you expect an answer, but yes, this is a good point. I mean, in our case, we took the figures from the European Commission regarding the grid, the CO2 content of the grid. Okay, but you are right on direct burning of fossil gas. Typically, I'm not sure we took a reference figure. It was more kind of average figure we see on the literature.
Okay, thank you very much. So let's close the Q&A, and if you can bear with us for one more minute, we would like to give you an overview of the next steps for the case study calculators. We will refine these two calculators early 2023. As Veronica said, we are still waiting for feedback from the advisory board, which will be taken into account for the finalization of these two calculators. We will then, by mid-2023, develop calculators for approximately 16 other solutions across all the priority sectors which have been identified. So it's transport, buildings, construction, energy, agriculture, smart cities, manufacturing. And then by the end of next year, we will develop guidelines to guide and optimize the deployment of the digital solutions that enable avoided emissions for each of the sectors. And these guidelines will be co-created with stakeholders from all the sectors. So we will also reach out to the relevant stakeholders among you to to provide your feedback on the guidelines. We are just a bit behind time, but thank you to everyone who has joined the meeting and the webinar, and for your interest in the EGDC results. As mentioned by Luis Neves, if you want to reach out, you can contact the Secretariat via the email address which is in the chat, or you can visit the website which is greendigitalcoalition.eu. And I can also just answer Andrea's question. The webinar recording will be made available. We will upload it to the EGDC website. We will also share it with all the participants of this meeting, so you will be informed when it's online. Thank you, everyone. We wish you a pleasant afternoon and nice holidays ahead.
Thank you, Deborah. Thank you.
Thank you.
Ciao,
ciao. Bye-bye.
Thank you. Gracias por la
Thank you so
oportunidad.
much, all. Have a nice weekend.
Thank you.